All right, let's get into it. Today we are deconstructing OpenStack. If you've ever wondered what it really takes to build a cloud from the ground up, not just be a consumer of one, then you are in exactly the right place. We're going to break down this incredible open source platform and see how it gives you the power to run your very own private and public clouds.
To really wrap our heads around OpenStack, let's start with a huge question. What if you could build your own version of AWS, or Azure, or Google Cloud? And I don't just mean using their services. I mean having the actual fundamental building blocks to create your own massively scalable infrastructure as a service platform from scratch. That, right there, is the core promise of OpenStack.
So at its heart, yes, OpenStack is a cloud computing platform. But the key thing to get is that it's not some single monolithic product. It's a framework, a collection of interconnected, API-driven services. You can think of them as components you can plug and play to build a cloud that's perfectly tailored to your needs. It's the engine behind countless IaaS deployments all over the world.
Okay, so here's our game plan to get a handle on all of this. We'll start with the big picture concept, then we'll meet the core services that make it all tick. After that, we'll look at the architecture, simulate launching a virtual machine, and then wrap up with the key takeaways every engineer should know.
So, let's start with the big idea. Probably the best way to think about OpenStack is as an operating system, but not for a single computer, for your entire data center. It's designed to abstract away all those messy pools of compute, storage, and networking resources into something clean that you can control programmatically.
And that Lego set analogy? It is absolutely perfect. OpenStack is basically a collection of independent projects. You can think of them as microservices that each have a very specific job. One service handles networking, another handles storage, another one manages user identity. The magic that holds it all together is that they all communicate through well-defined APIs. This modularity is its greatest strength because it's totally open source, so you can pick and choose the components you need, tweak them, and build a cloud that is a perfect fit for whatever you're doing.
All right, let's move on and meet the all-stars of the OpenStack world. Think of these services as a team of specialists, where each one is an expert in their own domain. We'll kick things off with the two most fundamental players, compute and networking.
First up is Nova. If OpenStack is our data center's operating system, the Nova is basically the kernel's process scheduler. It is the core compute service that manages the entire fleet of virtual machines, talking to the underlying hypervisors to orchestrate their whole lifecycle.
Nova is truly the brains of the compute operation. It handles everything from scheduling and creating VMs to powering them down. But, and this is critical, it does not do this alone. To do its job, Nova is constantly talking to other services through their APIs. It'll ask Keystone for an authentication token, it'll get the OS image details from Glance, and it'll request a virtual network port from Neutron. See, it's an orchestrator, not a monolith.
And that brings us right to Neutron. If Nova is managing the VMs, Neutron is managing how they all connect. It's like the city planner and the plumber, laying down all the virtual roads and pipes that connect everything together. It literally provides networking as a service. Neutron is responsible for creating and managing all of that virtual network infrastructure. And that includes everything from Layer 2 networks and Layer 3 subnets to virtual routers and floating IPs for getting out to the real world. Without Neutron, your VMs would just be these isolated little compute islands, completely unable to talk to each other or the internet. It is the connective tissue of your entire cloud.
Okay, so we have compute and we have networking. But a real cloud needs more than that, right? You need persistent storage, a solid identity management system, and of course, a user-friendly way to control it all. So let's meet the rest of the core team. When it comes to storage, OpenStack gives you two main flavors. On the left, you have Cinder, which provides block storage. The best way to think about this is as a virtual hard drive, kind of like AWS's EBS. You create a volume in Cinder and then attach it to your Nova VM for that persistent, high-performance storage. On the right, you have Swift, which provides object storage. This is your S3 equivalent, a massively scalable system for unstructured data like images, videos, backups, you name it.
And rounding out our core team are a few other absolutely critical services. Glance is the image service. Think of it as a catalog for all your bootable OS images, like AMIs and AWS. Keystone is the identity service. It is the gatekeeper, handling all authentication and authorization using tokens. Horizon is the dashboard. That's the graphical interface you'd log into to manage your cloud. And finally, there's Heat, the orchestration engine, which lets you define your entire infrastructure as code, very similar to CloudFormation.
So now that we've met all the individual players, let's see how they actually work together as a team.
This is where the real power of that modular, API-driven design starts to shine.
Okay, so this might look a little complex at first, but you can see all the services we've just talked about. There's Horizon at the top for the user, Nova in the compute block, Neutron for networking, and all the storage and shared services down below. The key takeaway here isn't to memorize every single connection, but to get the concept. This is the blueprint for how everything communicates. Every single interaction is an API call.
So let's follow a typical request through this system. It all starts with you, the user, making a request, maybe through the Horizon dashboard or a direct API call. That request's first stop is the Keystone endpoint to get an authentication token. Once you have that token, your next request gets routed to the right service. Let's say the Nova API to build a new server. Nova then becomes the conductor, making its own API calls to other services to gather everything it needs, and then provisions that VM on the actual physical hardware.
Let's make this even more real. We're going to walk through the most common task in any cloud environment, launching a brand new virtual machine. This is going to show you exactly how all those services talk to each other to get the job done.
Okay, imagine you're at the command line. First, you authenticate against Keystone to get a token back. That token is now your passport. You'll include it in the header of all your future requests. Next, you might query Glance to see what OS images are available. You pick one, and then you make the main API call to Nova. Hey, create me a server using this image and this flavor, which just means a certain amount of CPU and RAM. Nova gets that, and then it turns around and calls Neutron, saying, I need a network port for this new server. At the same time, you might tell Cinder to create a new 50 GB volume. And once that's ready, you make one final API call to Nova to attach this volume to my new server. It is a perfectly orchestrated dance of API calls.
So, after all that, what are the most important things you need to remember as an engineer who might be working with or thinking about OpenStack? Let's boil it all down.
This summary table is basically your cheat sheet. Nova is the general contractor for compute. Neutron is the plumber for networking. Glance is the library of OS images. Cinder provides your virtual hard drives, while Swift acts as the massive warehouse for your object data. And Keystone is the gatekeeper, controlling access to every single thing. Understanding these core roles and their analogies is honestly 90% of the battle.
And this brings us to the final and most crucial takeaway. Why go through all the trouble of having all these separate services? It's because this modular, loosely coupled architecture is the absolute key to building clouds that are resilient and can actually scale. If your networking service is getting hammered, you can scale just the Neutron controllers without ever touching compute. If one little component fails, it's way less likely to cause a catastrophic system-wide outage. This design is what gives OpenStack its power and flexibility.
So, in the end, OpenStack isn't just a product. It's a framework, and really a philosophy. It provides you with this incredibly robust set of open-source building blocks, the same kind that power some of the world's largest clouds. It gives you the ultimate control, but with that control comes responsibility. So the only question left is, what will you build with them?